Hi everyone, my name is Aria, and I work alongside Whitroy as an electrical tutor. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 3000, 2018. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for EWRB exam. What this audiobook does is take the key ideas from the standard and explain them in simple, spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real installations. So think of this as a learning companion, not a replacement for the actual standard. Alright, let's get started. Today we're moving into Section 3, Selection and Installation of Wiring Systems, which focuses on wiring systems. In this section, we'll look at how cables and wiring systems must be selected, installed, supported, protected, and enclosed so they remain safe throughout their service life. Everything in this section is about good installation practice, preventing damage, managing heat, allowing for movement, and making sure wiring systems are suitable for the environment they are installed in. This section sets out the practical rules electricians use every day on site, and it links closely with earlier safety principles to make sure installations remain reliable, durable, and safe under normal use and foreseeable conditions. Clause 3.1 General. This part explains that this section sets the minimum rules for choosing and installing wiring systems, and these rules must be met so the installation satisfies the overall safety requirements of the standard. Clause 3.1.1 Application. This clause means the requirements in this section apply to how wiring systems are selected and installed, and the goal is to meet the basic safety outcomes required by Part 1 of the standard. Clause 3.1.2 Selection and Installation. This clause explains that wiring systems must be chosen and installed so they work safely and correctly. They must protect people from touching live parts, either by strong insulation or by keeping live parts out of reach. They must be suitable for carrying current, controlling voltage drop, and meeting minimum size rules for conductors. Connections, joints, and terminations must be reliable and electrically continuous. Supports, suspensions, and fixings must be strong enough for the wiring system. The wiring system must suit its intended use, including special situations such as fire resistance, explosion protection, or safety services. It must be protected from mechanical damage and from environmental or other external effects, using enclosures or other suitable methods. Installation must follow the requirements of this section as well as any extra instructions given by the manufacturer. This clause also highlights that things like conductor material, core identification, insulation properties, temperature rise, bending limits, and tension limits must all be considered. Clause 3.2 Types of wiring systems. This clause states that the type of wiring system and how it is installed must either follow the options set out in Table 3.1 or provide an equivalent level of safety to what is given there. Clause 3.3 External influences. This clause introduces the idea that wiring systems must be able to work safely and properly under the environmental and other conditions they are likely to face at the place of installation. Clause 3.3.1 General. This clause explains that wiring systems must operate safely and function as intended in the conditions they are exposed to. Protection against environmental and other influences can be achieved through suitable design and construction of the wiring system itself, or by adding extra protective measures as part of the installation, as long as those measures do not interfere with normal operation. Clause 3.3.2 Particular influences. This clause signals that specific types of environmental and external conditions must be considered in more detail in the following clauses. Clause 3.3.2.1 Ambient temperature. This clause means wiring systems must be chosen and installed so they are suitable for the highest and lowest local ambient temperatures. Where materials have temperature limits above 60 degrees Celsius or below 0 degrees Celsius, the manufacturer's instructions must be followed. Allowance must be made for expansion of materials caused by normal temperature changes. Where current carrying capacity is selected using ASNZS 3008.1, the reference ambient temperature for New Zealand is 30 degrees Celsius for cables in air, and 15 degrees Celsius for cables buried in the ground or installed underground. Clause 3.3.2.2 External heat sources. This clause explains that wiring systems must be protected from heat coming from outside sources, including sunlight. Protection may be achieved by shielding, placing the wiring far enough away from the heat source, selecting a system that allows for extra temperature rise, limiting the current carried to reduce operating temperature, reinforcing or replacing insulation locally, or using another method that gives equivalent protection. Parts of cables or flexible cords within accessories, appliances, or luminaires must be suitable for the temperatures they will experience, or have extra insulation suited to those temperatures. Clause 3.3.2.3 Water or high humidity. This clause requires wiring systems to be selected and installed so that moisture or water entry does not cause damage. Where water may collect or condensation may form and create a hazard, provision must be made for safe drainage. Where wiring systems may be exposed to wave action or moving water, protection against excessive flexing and mechanical damage must be provided in line with the relevant clauses. Clause 3.3.2.4 Solid foreign bodies. This clause means wiring systems must be selected and installed to reduce the entry of solid objects during installation, use and maintenance. Where dust or other substances may be present in large amounts, extra precautions must be taken to prevent build-up that could reduce heat dissipation. Clause 3.3.2.5 Corrosive or polluting substances. This clause explains that where corrosive or polluting substances may cause deterioration, affected parts of the wiring system must be protected or made from materials that resist those substances. Metals that can cause galvanic action must not be placed in contact with each other. Materials that could cause deterioration or hazardous degradation must also not be placed together. Clause 3.3.2.6 Mechanical damage. This clause requires wiring systems to be selected and installed to reduce the risk of mechanical damage. Protection can be provided by the inherent strength of the wiring system, by choosing a suitable location, or by adding local or general mechanical protection, or by a combination of these methods. Clause 3.3.2.7 Vibration. This clause means wiring systems exposed to vibration that could cause damage, including cables, fixings, and connections, must be suitable for those conditions. Clause 3.3.2.8 Other mechanical stresses. This clause explains that wiring systems must be selected and installed to minimize damage to insulation, sheathing, and connections during installation, operation, and maintenance. Measures may include providing adequate supports at suitable intervals, using fixings that hold the cable without damage, using connections that reduce strain at joints and terminations, observing minimum bending radius limits, and allowing flexibility to accommodate movement or tension. Clause 3.3.2.9 Flora. This clause states that where plant growth is likely to create a hazard, the wiring system must be selected accordingly or special protective measures must be used. Clause 3.3.2.10 Fauna. This clause means that where animals are likely to create a hazard, the wiring system must be selected accordingly or protected by special measures. Clause 3.3.2.11 Solar radiation, direct sunlight. This clause explains that where wiring systems may be exposed to direct sunlight, they must either be suitable for those conditions or be adequately shielded. Sheathed cables exposed to sunlight generally do not need extra protection from ultraviolet radiation unless the manufacturer advises otherwise. Black insulated unsheathed cables with ultraviolet-resistant insulation that complies with ASNZS 3008 do not need extra protection. For other insulation colors, the manufacturer's advice should be followed or a physical barrier provided. Direct sunlight can affect current carrying capacity, and a correction factor may be applied where the cable temperature is higher than ambient. Clause 3.3.2.12 Hazardous areas. This clause states that wiring systems installed in areas with explosive gas or explosive dust atmospheres must be selected and installed in accordance with the relevant hazardous area requirements. Clause 3.3.2.13, Thermal insulation. This clause explains that where cables pass through bulk thermal insulation, their current carrying capacity must be rated according to the length of cable within the insulation. Short lengths up to 150 mm use the in-air rating, longer lengths up to 400 mm use the partially surrounded rating, and lengths greater than 400 mm use the completely surrounded rating. Clause 3.4, Current carrying capacity. This clause sets the overall requirement that conductors must be capable of carrying electrical current safely without overheating, and that current carrying capacity is a key factor in the selection and installation of wiring systems. Clause 3.4.1, General. This clause explains that every conductor must have a current carrying capacity selected in accordance with ASNZS 3008.1, and that this capacity must never be less than the current the conductor is expected to carry in service. When determining the required capacity, allowance must be made for changes that can reasonably be expected to occur over time, such as changes to the environment around the wiring. One specific example is domestic installations, where wiring systems must be installed on the assumption that thermal insulation may be added later in ceilings, walls, or under floors, even if it is not present at the time of installation. This requirement does not apply to existing wiring systems when a circuit is simply being extended or altered. Clause 3.4.2, Operating temperature limits. This clause states that conductors must operate within the temperature limits specified for their insulation type. The operating temperature must not exceed the limits set out for normal use or maximum permissible conditions. It also makes clear that polymeric cables with normal operating temperatures below 75 degrees Celsius are not considered suitable for use in Australia or New Zealand. The clause highlights that different cable insulation materials have different temperature limits, including limits for normal operation, short-term maximum temperature, and minimum ambient temperature, and these limits must be respected during installation and operation. Clause 3.4.3, Conductors in parallel. This clause explains how current carrying capacity is determined when conductors are connected in parallel. Where circuits use parallel multi-core cables or groups of single-core cables, the total current carrying capacity may be calculated as the sum of the capacities of the individual cables, provided certain conditions are satisfied. The cables must meet minimum size requirements, and the grouping of cables must not reduce their ability to cool in air or in the ground. The sharing of load current between parallel cables or groups must be sufficient to prevent overheating of any individual cable. Equal sharing of load current can be achieved by selecting cables of the same material and cross-sectional area, ensuring the cables follow the same route and have the same length, making sure the conductors of each parallel cable or group are effectively joined together at each end, and arranging phase and neutral conductors so that the effects of mutual impedance are taken into account. Unequal current sharing between cables or groups may be permitted where the design current and overcurrent protection for each cable or group are considered individually. Clause 3.4.4, Coordination between conductors and protective devices. This clause requires coordination between the continuous current carrying capacity of conductors and the rating of the protective devices used in the circuit. The cable capacity must be matched with the current for which the circuit is designed, as well as the type and rating of the overload protective device. Because fuses and circuit breakers have different operating characteristics, different limits apply. The current rating of a circuit breaker must not be greater than the current carrying capacity of the cable, and the current rating of an HRC fuse must not be greater than 90% of the cable current carrying capacity. Clause 3.5, Conductor size. This clause introduces the requirements that apply to the minimum physical size of conductors used in wiring systems. Clause 3.5.1, General. This clause states that the nominal cross-sectional area of conductors must not be less than the minimum values specified for the type of wiring system and the intended use of the circuit. These minimum sizes are set to ensure adequate current carrying capacity, mechanical strength, and reliable connections. Clause 3.5.2, Neutral conductor. This clause explains how the minimum size of a neutral conductor is determined. For a single-phase 2-wire circuit, the neutral conductor or conductors must have a current carrying capacity that is not less than that of the associated active conductor, or not less than the total current to be carried where more than one active conductor is present. For multiphase circuits, the neutral conductor must be sized so its current carrying capacity is not less than the value determined by the expected loading conditions. Where substantial harmonic currents may be present, such as from nonlinear loads, the third and higher order harmonic currents in the neutral must be taken as 100% of the highest load generated harmonic current on any phase. In consumer mains, submains, and final subcircuits, the current carrying capacity of the neutral conductor must not be less than that of the largest associated active conductor. Certain exceptions are allowed where abnormal conditions or protective arrangements limit the neutral current. Clause 3.5.2, PE in conductors. This clause states that where a combined protective earth and neutral conductor is used for consumer mains or submains forming a separate MEN installation, the minimum size of the PEN conductor must comply with the requirements that apply to active or neutral conductors as appropriate, and must also not be smaller than the size required for an earthing conductor. Clause 3.5.3, Earthing conductor. This clause explains that the size of an earthing conductor must be determined in accordance with the requirements set out in Clause 5.3.3. Clause 3.6, Voltage drop. This clause introduces the requirement to control voltage drop so that electrical equipment operates safely and correctly under normal service conditions. Clause 3.6.1, General. This clause explains that, during normal operation, the voltage available at the terminals of any power-consuming electrical equipment must not fall below the lower limit specified in the relevant equipment standard. Where no specific equipment standard exists, the voltage at the terminals must still be sufficient to ensure the equipment operates safely and properly without impairment. Clause 3.6.2, Value. This clause states that the cross-sectional area of every current-carrying conductor must be selected so that the voltage drop between the point of supply for the low-voltage installation and any point within that installation does not exceed 5% of the nominal supply voltage. The current value used when calculating voltage drop does not have to be greater than the total connected load, or the maximum demand of the circuit, or the current rating of the circuit protective device. This clause also explains that short-term transient effects, such as those caused by motor starting or similar operations that produce brief high currents, are not included in the voltage drop assessment. Simplified estimation methods and conductor size selection guidance are provided elsewhere, and special arrangements apply for reverse voltage rise in grid-connected inverter systems. Specific exceptions allow alternative limits in defined situations, including certain final subcircuits, installations supplied directly from on-site substations, and standalone systems where the overall voltage at equipment remains within acceptable limits. Clause 3.6.3, Conductors in parallel. This clause explains that where conductors are connected in parallel, the voltage drop for the circuit is taken as the voltage drop in one conductor carrying its share of the circuit current, with the total circuit current divided equally between the parallel conductors in accordance with the earlier voltage drop requirements. Clause 3.7, Electrical connections. This clause introduces the requirements for making electrical connections that are electrically sound, mechanically secure, and suitable for long-term service. Clause 3.7.1, General. This clause explains that connections between conductors, and between conductors and electrical equipment, must maintain electrical continuity, provide appropriate insulation, and have adequate mechanical strength. The method used to join or connect conductors must suit the application and ensure the conductivity of the joint is not less than that of the conductor itself. All cables and conductors must be installed so that no undue mechanical stress is placed on any connection. Clause 3.7.2, Connection methods. This clause introduces the acceptable methods and requirements for connecting conductors. Clause 3.7.2.1, General. This clause states that the selection of a connection method must take into account the conductor material and its insulation, the number and shape of wires forming the conductor, the cross-sectional area, the number of conductors being connected together, the temperature reached by terminals in normal service, and the need to prevent moisture entry or water siphoning through cables or enclosures. Clause 3.7.2.1.1 Common Requirements. This clause reinforces that all of these factors must be considered together so that the connection remains safe, insulated, and reliable in service. Clause 3.7.2.1.2 Aluminium conductors. This clause explains that joints and connections involving aluminium conductors must use components and techniques specifically designed for aluminium. Special considerations include removing aluminium oxide from the conductor, accounting for the softness of aluminium, allowing for different thermal expansion compared with other metals, and avoiding contact with dissimilar metals that could cause galvanic action. Clause 3.7.2.2 Preparation for connection. This clause states that insulation must only be removed as much as necessary to make the connection. Where insulated conductors are joined, the joint must be insulated to a level not inferior to the original conductor insulation, and any damaged insulation must be reinstated. Clause 3.7.2.3 Loosening of connections. This clause explains that connections must be made so that loosening is unlikely under normal service conditions, including vibration, material changes, and temperature variations. Clause 3.7.2.3.1 General. This clause reinforces that connections must remain secure throughout normal operation. Clause 3.7.2.3.2 Crimp joints, compression joints. This clause explains that crimped or compressed connections must be securely retained within a suitable crimping device and made using tools and techniques specified by the manufacturer. Clause 3.7.2.4 Mechanical connection devices. This clause states that mechanical connection devices may be used where they comply with the relevant standard, do not rely on compression of insulation for electrical contact, have suitable short-circuit ratings, provide long-term current carrying capacity not less than the connected conductors, do not deteriorate if reused where permitted, include manufacturer information for correct use, and are installed using approved techniques. Clause 3.7.2.5 Retention of stranded conductors. This clause explains that the ends of stranded conductors must be secured to prevent strands from spreading or escaping, and they must not be soft soldered before being clamped under screws or between metal surfaces. Clause 3.7.2.6 Mechanical stress. This clause requires that all cables and conductors be installed so that no undue mechanical stress is applied to any connection. Clause 3.7.2.7 Soldered connections. This clause explains that where soldered connections are used, the design must account for creep, mechanical stress, and temperature rise under fault conditions, and that soft soldered connections must not be clamped under screws or between metal surfaces. Clause 3.7.2.8 Flexible cords. This clause states that joints and flexible cords used as installation wiring must meet the same connection requirements or use suitable couplers, and that flexible cords must be installed so that pulling forces are relieved by proper means rather than knots. Clause 3.7.2.9 Aerial conductors. This clause introduces special rules for joints and connections in aerial conductors. Clause 3.7.2.9.1 Joints and connections. This clause explains that joints in aerial conductors under tension must not be soldered, must be reliable and well protected from movement, sunlight, and moisture, and must be kept as short as practicable. Where dissimilar metals are joined, measures must be taken to prevent galvanic action. Clause 3.7.2.9.2 Prohibited joints. This clause states that joints must not be made, when under tension, in certain types of cables including parallel webbed aerial cables, neutral screened cables, multi-core cables, or conductors of different metals. Clause 3.7.2.10 Underground cables. This clause explains that connections in underground wiring must be sealed to prevent moisture entry. Clause 3.7.2.11 Earthen conductors. This clause states that soldered earthing connections must be mechanically secured independently of the solder, and that tunnel-type terminals must be designed to clamp conductors effectively without cutting them. Clause 3.7.3, Joints in cables. This clause explains that joints in cables must normally be enclosed to protect against external influences, unless specific conditions are met, such as no undue strain, compliance with connection requirements, reinstated mechanical protection, and restored insulation and sheathing equivalent to the original cable. Clause 3.7.4, Installation couplers. This clause explains that installation couplers complying with ASNZS 61535 may be used as a permanent connection method for cables, are considered equivalent to a junction box, and are not intended to be connected or disconnected under load. Clause 3.8, Identification. This clause introduces the requirements for identifying conductors so their function is clear and unambiguous. Clause 3.8.1, General. This clause explains that installation wiring conductors must be clearly identified according to their function as active, neutral, earthing, or equipotential bonding conductors, and where color is used, the specified color system must be followed. Clause 3.8.2, Color identification. This clause introduces identification by color or by sleeving. Clause 3.8.2.1, Color identification by sleeving or other means. This clause explains that sleeving or other color identification methods may be used at terminations to identify conductors where appropriate, provided the identification is durable, color-fast, and compatible with the installation. Clause 3.8.2.2, Sleeving of existing earthing and bonding conductors. This clause explains that existing bare or green earthing or bonding conductors installed under previous rules may remain, but where alterations or repairs create new terminations, those conductors must be sleeved green and yellow at the new connection points. Clause 3.8.2.3, Sleeving of existing live conductors. This clause explains that existing live conductors with yellow insulation may remain, but where new terminations or joints are made, white sleeving must be applied at those new points. Clause 3.8.3, Exceptions and special applications. This clause introduces situations where the standard color rules do not apply. Clause 3.8.3.1, General. This clause explains that the standard color identification rules may be relaxed for specific applications covered in the following clauses. Clause 3.8.3.2, Protective earthing and equipotential bonding conductors. This clause explains that earthing conductors do not need to be green and yellow in certain cases, such as bare or aerial earthing conductors, suitable screens used as earthing conductors, insulated earthing conductors not manufactured in green and yellow, or multi-core cables with a dedicated green earth, provided clear identification is applied where needed. Clause 3.8.3.3, Active and neutral conductors. This clause explains that active and neutral conductors may use alternative identification methods where conductors are within multi-core cables and clearly marked. Flexible cords are identified by approved alternative colors, or neutral conductors are distinguished by physical features such as ribs. Clause 3.8.3.4, Alternative and European cable identification colors. This clause explains that alternative and European color systems exist, that care must be taken when connecting imported equipment, and that verification is necessary to confirm correct function and connection. Clause 3.8.3.5, Aerial earthing conductors. This clause states that aerial earthing conductors must be identified at each end of the run, either by the letter E or by the earthing symbol. Clause 3.9, Installation requirements. This clause sets out how wiring systems must be installed so they remain safe, reliable, and fit for service over their full life, taking into account normal use, foreseeable misuse, wear and environmental conditions. Clause 3.9.1, General. This clause explains that wiring systems must be installed using accepted good electrical practice. The methods used must protect the installation against mechanical damage, electrical failure, deterioration from normal wear, and abnormal conditions that can reasonably be expected. The overall intent is that the installation remains electrically sound and mechanically secure in everyday service. Clause 3.9.2 Methods of installation. This clause explains that common installation methods for wiring systems are recognized and set out elsewhere in the section. The effects of external influences at the installation location must always be considered, together with the manufacturer's instructions. Installation methods not specifically shown may still be used, provided the general safety and performance requirements of this section are met. Clause 3.9.3 Support and fixing. This clause introduces how wiring systems must be physically supported and fixed. Clause 3.9.3.1 General. This clause states that wiring systems must be supported by suitable means and fixed using clips, saddles, clamps, or similar devices that do not damage the cable and are not adversely affected by the wiring materials or the surrounding environment. Where wiring passes through building elements, openings must not weaken the structure below the limits required by building codes. Where sheath cables pass through metal structural members, edges must be treated to reduce abrasion. Where disturbance is likely, cables must be fixed close to the opening. Certain exceptions apply where wiring rests on a continuous immovable surface or where alternative fixing methods provide equivalent strength and support. Clause 3.9.3.2 Suspended ceilings. This clause explains that wiring systems in suspended ceilings may be supported by the ceiling system unless the ceiling manufacturer does not allow it. Where cables are in contact with conductive ceiling supports, additional mechanical protection is required. Wiring above suspended ceilings must be fixed at suitable intervals to prevent sagging. The clause clarifies that timber ceiling systems covered by other standards are not included. Clause 3.9.3.3 Wiring systems likely to be disturbed. This clause identifies locations where wiring is considered likely to be disturbed, such as accessible wall surfaces, areas beneath floors, ceiling spaces with sufficient access height, and locations close to access openings. Clause 3.9.3.3.2 Support and protection. This clause requires wiring in disturbed locations to be supported at suitable intervals, secured to prevent accidental withdrawal from equipment, and protected against mechanical damage. It clearly states that ASNZS must not be used as a substitute for mechanical protection where wiring is likely to be disturbed. Clause 3.9.4 Protection against mechanical damage. This clause sets out when and how wiring must be protected from physical damage. Clause 3.9.4.1 General. This clause states that wiring systems installed where mechanical damage may reasonably be expected must be adequately protected, using the methods specified later in this clause group. Clause 3.9.4.2 Wiring systems near building surfaces. This clause explains that wiring fixed or restrained close to walls, floors, ceilings, or roofs must be protected if it is within 50 mm of the surface. The intent is to prevent damage from nails, screws, or similar fixings. The requirement does not apply where the wiring can freely move away from the surface if penetration occurs. Clause 3.9.4.3 Wiring systems under wall lining or roofing material. This clause states that wiring must not be installed in the narrow spaces formed between wall or roof linings and their immediate supporting members, as these locations present a high risk of damage. Clause 3.9.4.3.2 Protection required. This clause explains that where wiring passes through structural members or is fixed close to supporting members, appropriate protection must be provided to reduce the risk of mechanical damage. Clause 3.9.4.4 Protection methods. This clause explains that protection may be achieved by providing adequate mechanical protection, by using earthed metallic protection capable of operating a short-circuit protective device under fault conditions, or by protection using an RCD with a maximum rated residual current of 30 mA. Additional notes clarify how these methods apply to different wiring systems. Clause 3.9.5 Wiring systems installed vertically. This clause explains that vertically installed wiring systems must be arranged to avoid damage caused by their own weight. Adequate support must be provided, with support spaced to prevent strain, typically not exceeding 8 meters unless otherwise recommended by the manufacturer. Clause 3.9.6, Change of direction. This clause requires that changes in direction must not damage cables or place stress on insulation or terminations. Manufacturer bending radius limits must be followed, or minimum acceptable radii applied where manufacturer information is not available. Supports in contact with cables under pressure must not have sharp edges. Clause 3.9.7, Particular installation requirements. This clause introduces additional rules for specific wiring systems and situations. Clause 3.9.7.1, Consumer mains. This clause explains that consumer mains protected on the supply side by a short-circuit protective device must comply with the installation requirements relevant to the wiring system used. Clause 3.9.7.1.2, Unprotected. This clause explains requirements for consumer mains that are not protected on the supply side. These must be constructed to minimize the risk of short-circuit and installed in accordance with additional distributor requirements. Certain wiring systems are recognized as providing adequate short-circuit risk reduction. Clause 3.9.7.2, Insulated and sheathed cables. This clause explains how insulated and sheathed cables may be installed in concrete, plaster, or cement render, with different rules for armored and unarmored cables to ensure adequate protection. Clause 3.9.7.3, Mineral insulated metal sheathed cables. This clause explains that MIMS cables must be selected to suit corrosion risk, underground installation, vibration and temperature conditions. Movement due to vibration must be managed by suitable cable looping, and supports must withstand the highest operating temperatures of the cable. Clause 3.9.7.4, Flexible cords used as installation wiring. This clause explains when flexible cords may be used as installation wiring, the conditions they must meet, and when flexible cords are not regarded as installation wiring. Clause 3.9.7.5, Low voltage track systems. This clause explains that low voltage track systems must be open to view along their length, positioned to minimize contamination, and supported at suitable intervals so the system remains secure and free from sagging. Clause 3.9.7.6, Under-carpet wiring systems. This clause explains that under-carpet wiring systems must be installed only as complete systems using specified components and tools, must not be interconnected unless permitted, and must be positioned so they remain safe under normal use. Clause 3.9.8, Prevention of mutual detrimental effects between services. This clause introduces the requirement to avoid harmful interactions between electrical wiring and other services. Clause 3.9.8.1, General. This clause explains that wiring systems must be arranged to avoid detrimental effects between different electrical installations, different voltage levels, safety services and non-electrical services. Clause 3.9.8.2, Different electrical installations. This clause states that conductors from different electrical installations must not share the same enclosure unless specific conditions apply, and clarifies what is not considered an enclosure. Clause 3.9.8.3, Segregation of different voltage levels. This clause explains that high voltage, low voltage, and extra low voltage circuits must be segregated unless specific insulation or physical separation arrangements are used. Clause 3.9.8.4, Proximity to non-electrical services. This clause explains separation requirements between electrical wiring and services such as gas, water and telecommunications, including minimum separation distances and applicable New Zealand requirements. Clause 3.9.9, Selection and installation to minimize the spread of fire. This clause introduces fire safety considerations for wiring systems. Clause 3.9.9.1, General. This clause explains that wiring systems must be selected and installed to minimize the spread of fire and must not reduce the fire performance of the building. Clause 3.9.9.2, Precautions. This clause explains that appropriate materials and installation methods must be used to reduce fire risk, and that fire-rated cables may be installed without additional precautions where suitable. Clause 3.9.9.3, Penetration of fire barriers. This clause explains that where wiring passes through fire-rated building elements, openings must be sealed, fire ratings reinstated, and sealing systems must resist fire, smoke, water, and combustion products. Clause 3.9.10 Limitation of circulating and eddy currents. This clause introduces requirements to limit heating caused by induced currents. Clause 3.9.10.1 General. This clause states that precautions must be taken to limit circulating and eddy currents. Clause 3.9.10.2 Cables for AC circuits, electromagnetic effects. This clause explains that single-core AC cables must be arranged so that all phase conductors and the neutral are contained together, especially in ferrous enclosures, to prevent excessive heating. Clause 3.9.10.3 Cables with non-ferrous metal sheathing. This clause explains bonding and arrangement requirements for single-core cables with non-ferrous metal sheaths, including trefoil and alternative formations. Clause 3.9.11 Minimization of electromagnetic interference. This clause explains that where sensitive equipment is present, electromagnetic interference may be reduced by suitable cable selection, shielding, or installation configurations that reduce magnetic field effects. Clause 3.10 Enclosure of cables. This clause explains when cables must be enclosed, what types of enclosures are acceptable, and how those enclosures must be installed so that cables are protected from damage and remain safe throughout their service life. Clause 3.10.1 General. This clause explains that some types of cables must be enclosed to provide mechanical protection, electrical safety, and durability, depending on how and where the cable is installed. Clause 3.10.1.1 Insulated, unsheathed cables. This clause explains that insulated, unsheathed cables must be enclosed in a wiring enclosure along their entire length. The purpose of this requirement is to protect the insulation from damage and to reduce the risk of electric shock or short circuit. The clause also explains that there are limited situations where an enclosure is not required, including where the cable is used as an aerial conductor in accordance with Clause 3.12. Where the cable is installed within an enclosed wall cavity close to an accessory and terminates within 100 mm of the opening, where the cable is inside switchboards or metering enclosures and not exposed to touch during normal operation, where the cable is an earthing or equipotential bonding conductor installed in accordance with Section 5, and where the cable is part of an extra low voltage circuit installed in accordance with Clause 7.5. Clause 3.10.1.2 Insulated and sheathed cables. This clause explains that insulated and sheathed cables generally do not need to be installed in a wiring enclosure because the sheath provides protection. However, if the insulation or sheath does not meet combustion propagation requirements, the cable must be installed in fire-rated enclosures. It also explains that where the sheath is removed, any exposed insulated cores must then be enclosed in accordance with the rules for insulated, unsheathed cables. Clause 3.10.2 Wiring enclosures. This clause introduces the requirements for wiring enclosures used to protect cables that require enclosure. Clause 3.10.2.1 Types. This clause explains the acceptable types of wiring enclosures. These include conduits complying with ASNZS 2053 or ASNZS 61386, such as steel conduit, flexible metal conduit, rigid or flexible insulating conduit, and corrugated insulating conduit. It also includes cable trunking systems complying with ASNZS 4296, with or without compound filling, and other enclosures that provide mechanical protection at least equivalent to conduit or trunking. The clause also explains that covers of wiring enclosures containing unsheathed cables must be securely retained and, where readily accessible, must not be removable without tools. Clause 3.10.2.2 Change of wiring enclosures. This clause explains that any change from one type of wiring enclosure to another must be made either at a switchboard or by using a suitable device that fully protects the conductor insulation and maintains continuity of conductive enclosures. Clause 3.10.2.3 Entry of water. This clause explains that wiring enclosures must be installed in a way that prevents water from entering electrical equipment or enclosures. Where enclosures are exposed to the weather, suitable measures must be provided to prevent rain entry. The clause also explains that the relative height of enclosure ends must be considered to reduce the risk of water tracking into equipment. Clause 3.10.3 Installation of wiring enclosures. This clause explains that wiring enclosures must be installed using safe and sound practice and must provide adequate protection in accordance with the requirements of Clause 3.3 and the following clauses. Clause 3.10.3.1 General. This clause explains that wiring enclosures must be installed so they do not obstruct natural water drainage on roofing materials and do not promote the buildup of debris. This may be achieved by installing the enclosure across the roofing profile or by installing it within valleys or trays using suitable supports such as standoff brackets. Clause 3.10.3.2 Support. This clause explains that wiring enclosures must be supported by suitable means to prevent damage to the enclosure or to the cables they contain. Clause 3.10.3.3 Continuity. This clause explains that mechanical and electrical continuity of conductive wiring enclosures must be maintained. An exception is allowed where the enclosure is not required to be earthed, such as where it contains insulated and sheathed cables only. Clause 3.10.3.4 Bending. This clause explains that bends in wiring enclosures must be made so that cables and conductors are not damaged. In rigid conduit, bends must not significantly reduce the internal diameter. Where direction changes occur in trunking or ducts, the arrangement must still allow cables to be bent without damage, and the cable bending requirements of Clause 3.9.6 must be met. Clause 3.10.3.5 Passage of conductors. This clause explains that conductors and cables passing through enclosures or openings must be adequately protected. Openings must be of suitable size and fitted with securely fixed bushes, or otherwise be free of sharp edges that could damage insulation or sheathing. Clause 3.10.3.6 Terminations. This clause explains that wiring enclosures must terminate at electrical equipment in a way that fully protects the enclosed cables as they enter the equipment. Flexible conduit must be securely anchored at each end to fixed conduit, structures, or equipment. Clause 3.10.3.7 Installation in direct sunlight. This clause explains that rigid insulating conduit fittings, and cable trunking systems installed in direct sunlight must either be designed for that use or be painted with a light-colored water-based acrylic paint to reduce heat and ultraviolet damage. Clause 3.10.3.8 Provision for expansion. This clause explains that allowance must be made for thermal expansion in runs of rigid insulating conduit. It also explains that insulating conduit expands with temperature, and that expansion must be accommodated to prevent stress or damage. Clause 3.10.3.9 Cable trunking. This clause explains that cable trunking systems must be installed so that covers can be opened where practicable. Covers remain continuous through walls and floors. Trunking is accessible along its entire length, and cables do not rely on removable covers for support. It also explains that non-hygroscopic trunking must be used for insulated, unsheathed conductors, and that live parts of accessories mounted on trunking must be arranged so that basic protection is provided. Clause 3.11 Underground wiring systems. This clause explains the requirements for wiring systems that are installed below ground. Underground wiring must be suitable for the environment it is placed in, protected against damage that could reasonably occur during excavation or ground movement, and installed in a way that reduces the risk of accidental contact or damage in the future. Clause 3.11.1 Suitability and protection. This clause explains that cables installed underground must be appropriate for the soil and environmental conditions they are exposed to. They must be protected against damage that could be caused by manual digging or mechanical excavation, and suitable warning, marking, or protective measures must be provided so that people carrying out excavation work are alerted to the presence of the underground wiring system. Clause 3.11.2 Classification of wiring systems. This clause explains that underground wiring systems are classified into 3 categories, and that the category depends on the type of cable used and the form of enclosure or protection provided. Category A systems are those that are inherently suitable for underground installation and do not require additional mechanical protection. Category B systems are suitable for underground installation only when extra mechanical protection is provided. Category C systems are those where cables are installed in a channel cut into rock and then covered with concrete. Clause 3.11.3, Category C underground wiring system. This clause explains that a Category C underground wiring system consists of cables installed in a channel that is cut into rock and then covered with concrete. It also explains that where a Category A system is installed in a channel cut into rock and meets the requirements for Category C, it may be treated as a Category C system. Clause 3.11.4, Installation requirements. This clause explains that underground wiring systems must be installed in accordance with the detailed installation requirements that follow, and that the dimensions and arrangements shown apply in any direction where cover is relied upon to reduce the risk of damage during excavation. Clause 3.11.4.1, General. This clause states that underground wiring systems must be installed in accordance with the requirements that follow in this section, and that these requirements are intended to reduce the risk of damage and improve safety over the life of the installation. Clause 3.11.4.2, Unenclosed. This clause explains that where Category A or Category B wiring systems use cables that are not installed in a wiring enclosure, the cables must be laid on a bed of sand or friable soil that is free from sharp stones. The bedding must be at least 50 mm thick, and the cables must then be covered with at least 50 mm of the same material before backfilling. Clause 3.11.4.3, Category B wiring system mechanical protection. This clause explains that Category B systems must be provided with additional mechanical protection. The protection must be placed no more than 75 mm above the cable, must be at least 150 mm wide, and must overlap the cable by at least 40 mm on each side. The protection may consist of materials such as concrete slabs, fibrous cement slabs, bricks designed for cable protection, polymeric cable cover strips, or other materials that provide an equivalent level of protection. Clause 3.11.4.4, Minimum depth of cover. This clause explains that underground wiring systems must be installed with not less than the minimum depth of cover specified for the category of system in the location. The depth is measured vertically from the surface of the ground or from the surface of any concrete placed above the wiring system, and the required depth varies depending on whether the wiring is within or outside a building and whether additional protection is provided. Clause 3.11.4.5, Identification of underground wiring. This clause explains that underground wiring systems must be identified by orange marker tape installed above the wiring system. The marker tape must be positioned at approximately half the depth between the surface and the cable, or above any additional mechanical protection. Where cables are installed in rock channels, the marker tape must be placed directly above the wiring system before the concrete is poured. Marker tape may be omitted for board installations if the cable route is permanently recorded and, where an enclosure remains after boring, that enclosure is colored orange. Clause 3.11.4.6, Marking and recording of underground cable location. This clause explains that permanent signs must be provided to show where an underground cable enters or leaves a building, unless the entry point is obvious. It also explains that the route of underground cables must be recorded on a plan so the location can be identified in the future. This plan must be kept at the switchboard where the circuit originates. Marking is not required for underground wiring installed entirely within the confines of a building. Clause 3.11.5, Spacing from other underground services. This clause explains that underground wiring systems must be separated from other underground services by at least 100 mm. They must also maintain separation from gas, water, and telecommunications services in accordance with the required spacing rules. Exceptions are allowed where multiple services are installed in a common trench, provided each service is in a separate enclosure and clearly identified. Clause 3.12, Aerial wiring systems. This clause explains that aerial wiring systems are used where cables are supported above ground, and that their use may be restricted by local authorities in some areas, especially where there is a higher risk such as bushfire zones. Clause 3.12.1 Types of conductor. This clause states that conductors used as aerial conductors must be suitable for aerial use, and this includes hard-drawn bare conductors, polymeric insulated cables, neutral screened cables, and insulated conductors that are twisted, bundled, or arranged together for aerial installation. Clause 3.12.2 Arrangements. This clause explains that aerial conductors must be arranged so they are safely installed and supported. It also introduces that further requirements apply to insulation, size, spacing, supports, and hardware, which are covered in the following clauses. Clause 3.12.3 Clearances. This clause explains that aerial conductors for low-voltage systems must be installed so that clearances from the ground, buildings, and other structures are not less than the minimum values required. These clearances must be maintained in all directions, taking into account sag caused by heat and movement caused by wind. When conductors are installed, extra allowance must be made so that the required clearances are still met at the maximum operating temperature. Where aerial conductors terminate near buildings or structures, suitable clearances must be provided to prevent contact. Connections between aerial conductors and circuit wiring are not treated as aerial conductors, but they must still be kept out of arm's reach from the ground or from accessible elevated areas. Clause 3.12.4 Distance between supports. This clause explains that the span length between supports for aerial conductors must not exceed the maximum values specified for the conductor type and size. Longer spans may be used only where the design follows sound engineering practice. This clause recognizes that correct span length helps control sag, tension, and mechanical stress on the conductors. Clause 3.12.5 Aerial conductor supports. This clause states that supports used for aerial conductors must be insulators or purpose-designed fittings that are suitable for the type of conductor being supported. It also explains that pin-type insulators must not be used where the strain on the conductor could cause it to lift or separate from the insulator, as this would create a safety risk. Clause 3.12.6 Poles and posts, including supports, struts and extensions to structures. This clause explains that poles and posts used to support aerial conductors must be made from materials suitable for the conditions of use. Their size and depth in the ground must be adequate to provide stability. Where ground conditions are poor, the depth must be increased or other stabilizing methods used. This ensures the support remains secure under load and environmental conditions. Clause 3.12.7 Joints and connections. This clause explains that all joints and connections in aerial conductors must be made in accordance with the general requirements for joints and connections. The intention is to ensure electrical reliability, mechanical strength, and long-term safety. Clause 3.13 Cables supported by a catenary. This clause introduces wiring systems where cables are supported by a separate catenary wire, rather than being self-supporting. It explains that this method reduces mechanical stress on the cable. Clause 3.13.1 Types of cables. This clause explains that cables supported by a catenary must be stranded cables that provide double insulation, or the equivalent level of insulation. Where installed outdoors, both the cable and the catenary support must be suitable for exposure to direct sunlight. Cables supported by a catenary are considered to be adequately supported because the catenary carries the mechanical load. Clause 3.13.2 Catenary supports. This clause explains that a catenary must provide even support along the cable run, be made from materials that resist corrosion and deterioration, be securely fixed at each end, be capable of withstanding expected mechanical stresses such as wind or ice, and be installed at a height that prevents danger to people, livestock, or damage to the cable. Where the catenary forms part of the cable, it must be installed in accordance with the manufacturer's instructions. Clause 3.13.3 Clearances. This clause explains that cables supported by a catenary must maintain minimum clearances. Outdoors, the clearances must meet the same requirements as those for neutral screened aerial cables. Indoors, The cable must be kept at least 100 mm away from moving parts or equipment that operates at elevated temperatures. Clause 3.14. Safety services. This clause states that wiring systems used for safety services must meet all the requirements of this section, and in addition must be installed in accordance with the specific requirements for safety services. This ensures that circuits supplying safety systems remain reliable and protected under fault or emergency conditions. Clause 3.15. Busways, including rising mains systems. This clause explains that busbar trunking systems, also called busways, must comply with ASNZS 61439.6 and must be installed exactly as the manufacturer instructs. When a busway is used as part of a wiring system, its installation must also meet the relevant installation requirements already set out in Clause 3.9. This means the same general rules for fixing, support, mechanical protection, and installation practice apply to busways as they do to other wiring systems, including the requirements that deal with penetration of fire-rated building elements. Clause 3.16. Earth sheath return (ESR) system. This clause explains that an earth sheath return system is a system where the copper sheath of a MIMS cable acts as a single conductor that performs two functions at the same time, being both the protective earthing conductor and the neutral conductor. Only a copper sheath is permitted to be used in this combined role, and it is referred to as a PEN conductor. These cables must be installed in accordance with Clause 3.9.7.3. along with the additional conditions set out in this clause. The copper sheath must have enough cross-sectional area and conductivity so it can safely carry both neutral current and earth fault current. The ESR system is only permitted in installations that use the MEN earthing system, and it must start at the point where the neutral and earthing conductors are connected together to form the MEN connection. If at any point the combined protective earthing and neutral conductor is changed so that the neutral and the protective earth become separate conductors supplying electrical equipment, they must not be recombined later to form another PEN conductor. The ESR system must not be installed in hazardous areas. Conductors used in an ESR system must not be smaller than 2.5 square millimeters. At every joint in the cable sheath, and at all terminations, the continuity of the combined PEN conductor must be maintained, and this must be ensured by using a bonding conductor in addition to whatever sealing and clamping method is used on the external conductor. The resistance of this bonding conductor at joints must not be greater than the resistance of the cable sheath itself. At terminations, two separate conductors must be used, one for protective earthing and one for the neutral. The minimum size of the protective earthing conductor must comply with Clause 5.3.3 in Table 5.1, and the neutral conductor must be not less than 6 square millimeters, or comply with Clause 3.5.2. Where several cables are associated together, such as single-core cables used in a multi-phase circuit, the cables must be arranged in accordance with Clause 3.9.10.3. The circuit must be clearly identified at the switchboard where it originates so it is obvious that the circuit uses an ESR system. No switch is allowed to operate in the combined protective earthing and neutral conductor of an ESR system. Only electrical fittings that are specifically identified as suitable for use with an ESR system are permitted to be used. Circuits that use ESR systems cannot be protected by RCDs. That brings us to the end of Section 3. We've now covered the key requirements for wiring systems, including how they are installed, supported, protected, enclosed, run underground, installed overhead, and used for special systems such as safety services and earth sheath return systems. These rules are essential for ensuring wiring systems are safe, durable, and fit for purpose over their entire life. As we move on, the next section will build on this foundation and look at further requirements that apply to specific situations within electrical installations.